In this video, I'm going to go over the first question from these free response problems about limits. Again, just a reminder for this test for this school year. This could be different if you're watching this from a couple years from now. But for this test for this year, we're not going to have any free response questions on our current test. But I did want to show you how they might ask you on the AP exam to do some of these concepts that we've been talking about with limits, but in the free response section. All right, so this is a non-calculator question. All right, so the first question is talking about this piecewise function, and it says, for what value of k, if any, is f continuous at x equals -2? All right, so we've been talking a lot about continuity in this unit, and if we're going to have a continuous function at a certain x value, then we really need to have three things. We first need to, I guess really two things. We really need to first look at the limit of this function, so of f of x, as x approaches -2 from the left, has to be equal to the limit as x approaches -2 from the right. All right, and if that's true, then the limit would exist. And then all of that has to be equal to when I plug in -2 into this function. So I know it looks like there's three things, which that's fine, but really my brain kind of groups these two to make sure the limit exists as x approaches -2, and whatever that limit is must be equal to the same value when I plug in -2 in the function. So if all that's true, then I know that x is continuous at this, or excuse me, the function is continuous at this x value. So I'm going to first plug in -2. So I'm going to do it over here. F of -2 would be using this piece, and I'm going to do -2 cubed and then plus 2. So -2 cubed plus 2, which is -8 plus 2, which is -6. Okay? So that means as I do the limit, as x approaches -2 from the left and from the right, it must also be -6. All right? Well, the limit as x approaches -2 from the right is actually what I just found, right? Because it has this or equal to piece, then when I plug it in from the right, I just plug it into that piece there and got -6. So that one is already good. So really I'm focused on this piece over here where I have to find it using my first piece of this piecewise function and hope that I can find a k value that would make this true. So I'm going to say that when I plug in -2 into the piece that is, again, from the left of -2, which is breaking the rule, so plus k times -2 minus 2 over 3 times -2 squared plus 4 times -2 plus 3. All right, so what's going to happen here is this needs to be the same as -6. All right, so I'm hoping when I plug this in, I need a k value that's going to get me -6. So let's do some math here. That's 4 in the first piece. Minus 2 is 2. So that's going to be 2 minus 2k on top over, let's see what all this is. That's 12 plus a -8, which is 4 plus 3 is 7. And now I'm just using algebra to solve for my k. So if I move over here, I have 2 minus 2k, move the 7 over and get -42. Get -2k equals, subtract 2, get -44. So k must be equal to a positive 22 for this function to be continuous at x equals -2. So, but again, my justification, right, what they're looking for on the AP exam for to justify your answer is this that I mentioned at the beginning, that all those must be true. All those must be the same. Okay, let's do part B. It says, what type of discontinuity does the function f have at x equals 0? Give a reason for your answer. Well, so when I look at finding this discontinuity here, I'm going to first find the limit as x approaches 0 from the left, and then I'm going to find the limit as x approaches 0 from the right. All right, I want to see what happens as I look at both of those pieces. So if I'm going from the left, I'm going to use this piece right here. So I'm going to plug in 0 into x cubed plus 2. So I'm going to do 0 into x cubed plus 2, and that gives me 2. And then from the right would be this piece down here with the rational function including some exponential, the letter e. So I have 2 times e to the 0 power over 2 minus e to the 0 power. I'm going to zoom in there. Anything to the 0 power, whether it's e, whether it's a different number, is just 1. So that's going to be 2 times 1 over 2 minus 1, which 2 over 1 is 2. And if you notice, we got the same value. So because these are equal to each other, I know that the limit as x approaches 0 is 2. But if you look at the actual piecewise function, if I plug in f of 0, right, I'm using this third piece, f of 0 is 0. So essentially, how I would give my reason for the answer is I'm going to say this has removable discontinuity, right? So essentially the fancy way to say whole. A removable discontinuity because the limit as x approaches 0 is equal to 2, but this is not equal to f of 0, right? F of 0 is going to be 0, so we have a discontinuity at x equals 0, and that type of discontinuity is removable. There's a hole there, right? So you're approaching 2 as you move towards 0 from the left and to the right in the x direction. You approach 2 in the y value, but there would be an open circle there and be a closed circle at 0, 2. No, I'm not going to sketch it. Okay, let's go to C. This is the last piece. It says find all horizontal asymptotes to the graph of f. Okay, so the key thing here when it says horizontal asymptotes is that it wants you to think about moving in the x direction to the right and to the left forever. And as you do that, you should approach a number. And if you do, that's called a horizontal asymptote. So essentially, with our understanding of limits, I'm going to find the limit as x approaches positive infinity of this function, and then the limit as x approaches negative infinity of this function. If I can find out what those are equal to, then I will figure out my horizontal asymptotes. So I'm going to do the one that actually approaches negative infinity first. So that would mean looking at this first piece because I want my values going to the left forever. So I'm going to look at x squared plus kx minus 2. So x squared plus kx, and it really doesn't matter if you decide to put in the k to make it continuous, it doesn't end up mattering, plus kx minus 2 over 3x squared plus 4x plus 3. So 3x squared plus 4x plus 3. Now, this is one of those rational functions that you would have learned about in pre-calculus, where if you notice the degrees are the same. So to find a horizontal asymptote of a rational function with the degrees being the same, the horizontal asymptote, the horizontal asymptote is going to be y equals the leading coefficient of the top, which is a 1, over the leading coefficient of the bottom, which is a 3. So this horizontal asymptote would be 1/3. All right. Let's talk about the other one. The other one is when you're approaching positive infinity, which would be my last piece because we want values moving to the right forever. So I'm going to write down 2 times e to the x, so 2 times e to the x, over 2 minus e to the x. Okay, now I'm going to go ahead and do a little factoring here. And let me actually rewrite this. So 2e to the x over 2 minus e to the x. I'm going to do a little factoring in the bottom and factor out a negative and write this as e to the x minus 2 in the bottom. And then I'm going to put that negative out front and just write 2e to the x over e to the x minus 2. All right, so here's what I want you to kind of think about. So if we're moving to the right forever, that means we're approaching infinity. So we're talking about plugging in for x, really, really large numbers. So if I think about writing this as e to the infinity power, I'm going to get a massive number, right? So the idea is in the denominator, if you look there in the denominator, you have a massive number minus 2. And if you've got a huge number, like billions, and you just want to subtract 2, that's really not going to change it. I mean, yes, I know technically it changes it, but the change is so small, it's almost as if it doesn't matter. So what I want your brain to think is that really this is just the opposite of 2 to the e to the x over e to the x. And so what happens is that these are just going to cross out, the e to the power of x, and it leaves you with that negative 2. So the horizontal asymptote would be, for this piece, as we move to the left forever, would be y equals negative 2. So we really have two answers here, and the kind of the work and my justification is because as I move in the x direction, far to the left and far to the right, then I am approaching these y values. All right, so that's it for this first piece or first question. And remember, just for this year, we're not worried about any free response on the test. But good luck. Make sure you prepare for the exam.